I've mounted the two gears onto my depthing tool, which is a homemade one made from a brass hinge and bits of brass glued and screwed to it. It looks a bit Heath Robinson, but actually it works quite well. And these tubes of brass were glued and then screwed on in position here, and these were all lined up as one rod when they were first glued together. There's a spring on here to hold it shut and an adjustment to be able to open and close it. Now just check the depthing where it runs most happily, which is at that point there. There's no sign of any binding in either direction, and this is only motion work, so there's no force behind it, but actually that's really quite good. I'm pleased with that. Now I could use my other wheel, but I'm slightly worried that these teeth might snap off, so I'll go with this one here where they're a little, I made them a bit tougher. So that's that part of it, which I'm happy with. The next thing is, what distance have we got between the centres? Now the calculations I have is that the pitch circle diameter of the crown pinion is 44, and the pitch circle diameter of the larger wheel is 66. That's 110, and if I divide by 2, the distance between those two centres should be 55 millimeters. And as you can see on there, it is exactly 55 millimeters. So I'm happy that that's correct, because this is slightly more complicated. There's a second set of gearing which has to fit to turn the other hand, and I need to fit this wheel on and this pinion on, and I haven't made a bush yet to fit the pinion, but I'm pretty sure that that will be adequately depthed, because the pitch circle diameter for those two wheels is also 55, and I'm sure that I've made that the right size. So yes, that's going to turn out fine for the motion work. I could have done this wheel, which I'm sure Harrison would have done, with vertical grained oak, but the way I've done it here turned out of solid and then machined using boxwood is perfectly adequate alternative. He did use boxwood, and it's not too far from what he might have done. So yes, that's part of the motion work finished. I've just got to put facings on each side, and then there's the large month going wheel which I've got to yet make, and then that finishes all the wheels and I can start on the pinion. Next job is to cut out the shape for the discs to go on here. I just centre punch a mark and do it with the calipers. Take that over to the drill and pop a centre drill through. Slightly small size. And the next thing is I'll take it over to the scroll saw and cut round. I've now cut the outside of these to fit. The hole in the middle is a little bit smaller because when you turn this over you'll see that that hole doesn't match up, and you don't have to worry too much about getting it absolutely perfectly concentric, because this also will move around a little bit when it's glued and you may not get it absolutely spot on. So having this undersize is better, because you can then open up the hole afterwards. So I'll glue these and put them on the bench over on the other side, where I stick them down to the bench. I've discovered that's the best way. Now this is where I do the gluing. You'd think it was an easy job, but you need to just give a little bit of thought to it. You want to have the orientation of the grain in the appropriate direction, and this is 3-ply, so that and that go that way, so I guess that's the best way to put that there, like that. And then the next thing is, after having put the glue on the surfaces, I put the tape across and glue it and stick it down to here before then weighting it up. When gluing, I've also found best to put the glue on both surfaces and have a thin layer rather than a thick layer, because you don't want the glue oozing out either in the middle or on the outside too far, because it's a bit of a pain to clean up. Just wants to be up to where the root of the teeth are, and it doesn't want to go over the edge. And the disc is the easy one to do. It just needs a very thin coat, but it needs to be glued all over. I've got that in the correct direction. Got it as centralised as I can. And I've discovered when you put the tape on, it helps centralise it a bit. Otherwise they tend to skate around on top of each other. Around to see if I've got it in here as I can. Put some nice heavy weights on top. And leave that now until it's gone well dry. The last operation to do, now that I've faced both sides of this, is to true up if there's any eccentricity on the outside veneer that I've added. I have to be very careful not to turn into the teeth, but it does spend a little bit of time just truing that up is worth doing. And I'll also thin off the side of this, because there's a number of gear teeth stacked on top of one another, and this is one way of just thinning them down a little bit. So I'll probably reduce the veneer thickness by about half. I think this is 1.6mm that I've got on here. It's a bit thick really. So I'll just give this a trim up. You can see it's wobbling a little bit. Check close up whether it's down. It's not quite down to the root of the tooth. Yeah, I think that's pretty good. Face off this. I should probably be able to have just enough friction on here to be able to face off the little bit left. So I'm very careful. That side done. There we go. This only just needs a fraction off the side. The only remaining thing to do is to clean up any of the residue of the glue. See if I can manage to get this so that you can see it. Yes, there we go. Just there you can probably make out there's a little blob of glue that's oozed out. So I'll go through now and clean up the roots of all of those. And that's the final cleaned up wheel with no glue, all taken off. So that's the wheel duly complete. So it's the same process for making all the wheels. It's just the shape of the teeth and the size, the thickness of the teeth that varies between one wheel and another. And this is the one that's the pointed form, like an ordinary gear profile. Yes, that's turned out quite well. This is the motion work that drives the clock hour hand, and I've had spent a bit of time, well, in fact quite a lot of time, getting the gear profile on the teeth absolutely correct. It's all done by hand filing, and what I've done is that I've moved this round slowly, and if the teeth have butted I've marked them, then gone back in and filed them until they're all exactly the same. So I'm very pleased that that now is correct, and this is sitting at 55 millimeters centres, which is correct. So if I take this off, this is the rear view of the motion work. That's the cannon pinion. That is the wheel that takes power from the going part of the clock and runs for the 60 minutes for 1 hour. So that gets this shaft running at 1 hour revolution per revolution. And then on this side, so you can see that those mate perfectly. See, I haven't glued the wheel onto the shaft yet. I haven't made the collets up, but you can see that they do mate correctly. So that's the motion work, and then there's one more wheel which comes in, and that goes down at the bottom, and that runs the date. And there's a set of pins in this wheel on this other side. Turn this round. On this side there's a set of pins, and that turns this. So the next job will be to start making collets and mountings and that sort of thing, but all the gear wheels are now finished. Everything so far mates nicely. Found in the past that actually the lantern pinions with rollers in are very much easier to get to mate correctly than ones that are using the correct tooth profile, especially if you haven't got an accurate cutter, as I hadn't for these. So you can do it by filing by hand, but it does take a little time to do. I'm now starting to check how the motion work will fit on, and I've made up a bracket for the motion work, and this has 2 dowels either side and a dowel in the middle with a pin through it, and its centre here goes through that cross on there. So when that is in that position, the wheel's not glued in yet, so it's wobbling a bit. But that's how it works. Now, this is slightly unusual because each of these 2 hands on here are not capable of independent adjustment. They're actually permanently linked together, and the reason for that is that on this wheel there's going to be a lead weight to counteract the weight of the hand. On the wheel on the back there's also going to be a lead weight to counteract the wheel on counteract the hand on the back of there, because otherwise the motion work requires more effort to drive it. I have put counterbalance weights on motion work before, This is the first time I thought about putting it on a wooden clock, I must say. So that, more or less, I'm happy that that's going to fit there like that. So the next job is to make a centre mark on here. I'll take all this off and then drill through, I'll make a centre mark on here, and then I'll make sure that this is centred over its position. So I'll make up a rod here that sits in that mark, and then I can drill these holes here while it's in position. So that's where I'm at now, and when I've done, I'll come back to you when I've got that fastened in. I've now drilled these 3 holes here. Unfortunately it's a little bit burred up, that one, anyway it'll clean up. And I've held those on with engineer's clamps while it was drilling, having previously marked on both sides where that had to go, having spotted through the middle of the hole in the centre there onto the crosshairs that I've got down below, and that seems to have worked okay. I've now fitted the support for the central arbor. And I just have to make sure now that this stands proud enough to allow the hands to be on the other side of the faceplate. And the faceplate is, well, it's to apply the same size. It's a little bit tight, so I think I'll probably remake this section here so it sticks out about 2 or 3 millimeters more. I think the front one will be alright. So I've got to put a square on there to hold the minute hand, and that will be held on with a pin cross drilled through, and it's it is a little bit tight. Anyway, it'd be fairly easy to make a new arbor through there. I've redone it once already because I hadn't quite got it long enough. Anyway, the benefit of anyone following what I'm doing, they'll know it will work. But anyway, this needs a pin through here still, and needs a little bit shortening. That I think I can take that down a little bit. So that just has one pin through it to hold it. And those hold it nicely there. Quite a sensible arrangement, really. Oh, and there's a spring that gets fitted behind the back of this wheel so that the wheels can be adjusted in relation to the train. So you can wind the minute hand on, giving the same relationship to the hour hand, and with the hand in the same position in relation to the lead weights, because clearly they can't be at a different position. So I've understood how that works, although I've got almost no drawings or photographs of that. That seems to be fine now. This is my setup for doing drilling into the face of something. It's very straightforward. I have an index wheel on the back of the lathe, and my Potts milling spindle, but facing the other way than when I'm cutting teeth, and it's a brushless motor that's in there, so it's just adequate speed the way it is. I could speed it up a bit by changing pulleys, but there really isn't any need. It works fine like that, and it's a variable speed. So I now need to drill the 21 holes, so I'll get on and do that now. door. Like that. Make sure that's the right size of hole for 2mm. It's not too, yeah, that's perfect. It's a tight fit, tightish fit, so that will do me fine. Get back to the start. There we go. Right. That's those done, and I can just show you the back of the lathe so you can see how the division is done. It's very simple. I've marked on with Sharpie on here every third wheel, because that's every third position, because that's 63 holes in that row, and I want 21, and it's a spring-loaded plunger like that. Works very well, nice and reliable, and I've never had a problem with it. And it's an expanding mandrel in the back of the headstock.